Section 4, electric motors, Unit 19, motor controls.
Very good.
Objectives. After studying this unit, you should be able to describe the differences between a relay, a contactor, and a starter. List how the locked rotor current of a motor affects the choice of a motor starter. List the basic components of a contactor and starter.
Objective continue. Compare two types of external motor overload protection. Describe conditions that must be considered when resetting safety devices to restart electric motors.
Introduction to motor control devices. Relays, contactors, and starters pass power to the motor by closing sets of contacts. Contacts controlled by coils in the control circuit. Starting relays are only in the active circuit for a short period of time. Determined by the size and application of the motor used.
Okay, your first cartoon of the day shows a contactor. You can tell it's a contactor because it says contactor.
Yeah.
And there's two normally open contacts, like the one in the back there. There's two normally open contacts, right? Okay, this is showing that, this is a magnetic relay, potential relay. Remember that? Potential means what? Volts, right? It's showing it's how it's wired in the system with T1, T2. Okay. That's what happens when they close the circuit breaker.
They gotta restart, Steve.
Huh?
They gotta restart.
I don't think so. That's good. We can cut it out later.
Okay.
Okay, so anyway, that's all that is.
Run, load, and lock rotor amperage. Running load amperage, similar to full load amperage, amperage drawn while operating. Lock rotor amperage 5 to 7 times greater than RLA or FLA amperage drawn on starter. Both RLA and LRA must be considered when choosing a control device.
Okay, so you guys got that? Lock rotor? You got that?
The relay uses a magnetic coil or coils one of the or more sets of electric contacts. Relays are not required to replace on failure. Used for light duty applications, can be used as a pilot duty relay. The relay contacts must be able to handle the amperage draw of the load being controlled.
Ah, another cartoon. Double pole, single throw relay. Two open sets of contact. That could be a contact. Two open sets of contact, right? Ooh. What about this guy here? Ooh,
Two sets of contacts.
that are open and one set that's closed. Oh, so when the coil energizes, what happens?
Two that are open, two that are closed, and one that is open.
They switch positions,
Uh,
right? So that opens and these close, right? Right? Man, yeah, you're smart.
Suppose.
The contactor, larger version of the relay, has movable and stationary contacts. Holding coils are rated at different voltages. Can have one or more sets of contacts. Some are equipped with auxiliary contacts. Contacts and coils can be replaced. Use the exact replacement whenever possible.
There you go, right there. Here's some contactors in action. You see some circuit breakers up here, got some current sensing coils there, and then the contactors down here. Right, it's a commercial unit. Isn't that exciting? Huh? The picture's in the book. Here's a cartoon for you. Pay attention. L1 and L2. See that?
Mm-hmm.
Okay. Single pole contactor. Have you seen one of those?
Things you did.
Like the board yesterday?
Yeah. They've got single poles on them. Yeah. Single pole contactor. This is the exciting part about this. This is magic. Closes that contact, starts that motor,
Correct.
right?
Mm-hmm.
When it stops, opens that contact, and what do you get? What kind of voltage do you get across an open switch? Nothing?
Zero.
Yeah.
Open,
Open.
switch. What do you get? What do you get across open switch? The applied voltage. Come on,
That was my next answer.
you had a 50-50 shot.
I really did.
So you're gonna get the entire L1 and L2 across that switch. So when the compressor's off, guess what?
The power's
The
electric.
crankcase heater heats up. Keeps that compressor warm when it's not running. As soon as it runs, what do you read across the closed switch?
Zero. Guessing that's when it's zero.
Okay, so power cuts off. Power turns on when the unit's off. Isn't that amazing how they do that?
Technology.
Magic.
Not magic, it's technology.
You said it's magic.
Huh?
You said it's magic.
Yeah, it's kind of. Here's another way. There's another way they're gonna use the energized crankcase heater on the off cycle. The 3-pole contact, and generally, if you have a 3-pole contactor, sometimes they'll have an option for a auxiliary contact that actually snaps onto that contactor itself. Just snaps on, locks in. So whenever that contactor closes, it pushes a lever down and it does something to the set of contacts, which is normally open or normally closed. You can do whatever you want with it. Be normally open or normally closed. In this case, it's normally closed. So when the unit is off, the contacts are closed, energizing the crankcase heater. When the unit turns on, this opens. And it's closed. So that's another way they're gonna do that, to turn the crankcase heater on and off as needed. Right?
Wowzers.
You guys know what that is, don't you?
Is it the
Starter. The starter here has an auxiliary contact right here. Bet you didn't know that.
No, I did not.
You didn't notice that when you were looking at it? Aux contact, it's called an aux.
I barely even see it.
You can barely even see it. Wow.
I mean, black on black, you know, like. That's all I'm saying.
This is a starter because it has an overload on it. Okay? Otherwise, it'd be, if it didn't have this, it would just be a big contactor.
Motor protection. Motors are expensive and must be protected. Fuses and circuit breakers protect the entire circuit, not the individual circuit components. Motors can operate under an overcurrent condition for a short period of time. Motor protection continued. Most small motors have no overload protection. The larger the motor, the more elaborate the method of motor protection should be. Motor protection can be inherent, internal, or external.
Okay, so what does inherent mean?
Internal.
Internal.
Internal, okay. Okay, so another cartoon for you. You have a condenser fan motor that's running about 3 amps, right? Compressor, it's running about 23 amps, right? So how many amps is that? 26 amps. Okay, so in this case, what they're doing is they're fusing the entire condensing unit with some fuses, and they're gonna be rated according to that condensing unit's MOCP. What's an MOCP?
Method of current protection.
Sounds good.
What is it?
I don't have the clue.
Maximum overcurrent.
Protection. See, you're good.
I beat you to it.
That was actually.
Okay, so that's what those sizes, those fuses are gonna be sizes for. So it's not gonna be 23 amps, not gonna be 3 amps, it's gonna be about 30 amps probably. Okay? That's in the disconnect itself. It's the fuse disconnect. We have those, yeah, all of this here. Yeah? Good. What does inherent mean?
Internal.
Okay. What does it say?
Inherent motor protection. Internal thermal overloads, usually embedded in the motor winding, sorry, I don't know. Open on the rise in temperature. External thermal overloads. Thermally activated bimetal snap disc located on the compressor internal shell, exterior shell.
Okay, so the internal, all these motors have internals. They got internals in them, even the bigger ones. The external overloads are gonna be extra, that are put on extra, if so desired. The snap disc is one that goes right on top of the compressor shell. Like the compressor we checked out,
Mm-hmm.
there was a spot for that, I'd taken it off,
Oh,
they use it somewhere else. Then there's other types of externals too. Now we're gonna go into externals.
External motor protection. Devices that pass power to the holding coil of the starter or contactor. Devices open when an overcurrent condition exists. The trip point and type of overload protector are determined by the manufacturer. The overload devices takes the service factor of the motor into consideration.
Oh, there's that term. What's that? What's the service factor?
service factor is
Reserve horsepower. Wow.
National Electric Code Standards. Set standards for electrical installation, conductor sizes and amperages, cable materials and applications, electrical devices. Set standards for overload protection. Consult published code book if questions, concerns are encountered on the job.
Okay, so, remember me telling you this? National Electrical Code is in charge of sizing those overloads,
Uh-huh.
and those are the ones that are in charge. These are heaters. Overloads with heaters.
Overload heater.
Yeah. So the National Electrical Code is the one who's gonna determine what size heaters go on what motor.
Temperature sensing devices, bimetal elements, heaters wired in series with load, exposed to the current draw of load, bimetal wraps, or warps / opens when it gets too hot. Then de-energizes the starter holding coil, solder pot, uses, solder with low melting point, solder melts with excessive temperature resulting from the overcurrent condition.
Okay, so the bimetal elements, the heaters, that's what they're talking about here. Those. The solder pot? Oh, the solder pot. Oh.
Ooh,
Is that in the book?
yeah,
In the book?
more likely.
What page?
783.
783. I don't
Okay.
even know what section it is.
What page? What? Where are we at? 19?
Uh-huh.
That's 19. Okay, so the solder pot is an overload device, and there's a picture of it. Where? There it is, right there, 476. There's a picture of a solder pot. I've never seen one, so I don't even know what they look like, so.
So, during her career of working in HVAC, you never seen one?
Never seen it. No. Although I might have seen one and not know what it was.
Like in the beginning of your career?
So the solder pot is a resettable device. So it resets once the solder hardens back up. Now, we'll talk about some other overloads here too. Ooh.
Magnetic overload devices. Accurate means to provide overload protection. Device is not attached to the starter. Device is not affected by increased ambient temperatures. The contacts within the device will open to de-energize the motor at the desired amperage level.
Okay, so magnetic starter with a picture on 477 with a magnetic overload is probably the best way to sense overcurrent protection because it does not, it's not affected by the heat of outside air or whatever temperature. Not like a circuit breaker, fuse, like a solder pot is all affected by temperature. Okay, so probably the best means of overload protection is magnetic. Okay?
Restarting the motor. Do not restart immediately. Cause for overload condition must first be located and repaired. Motor must be given ample time to cool. Many control devices are manually reset. Some controls reset automatically after a predetermined time delay. Time delay feature prevents short cycle.
Okay, so it says do not restart that motor if you see it go off. Okay, depending on how big it is, you could do some damage. Okay, any motor you turn off and on, turn on again, turn off, turn on, it's gonna murder that motor. Okay.
Summary, relay, contactors and start pass powered to motor. Contactors controlled by control circuits holding coils. Relays are used for light duty. Contactors for heavy duty applications. Starters have built-in overloads.
contacts on contactors and starters can be replaced. Fuses and circuit breakers protect the entire circuit, not the individual circuit components. Motor protection can be inherent or external.
You like that? Just in time, Josh.
Consultation